And we are live. So, thank you everybody for joining us for yet another event of WITS Mumbai and Kerala. I would like to just begin by sharing a quick intro on what WITS is. I'll just play a video.
Data-driven decision-making is at the heart of so much in the world right now. We're making decisions not just for us now, but for future generations as well.
The connection to data science is becoming more and more important to the work. The work has been going on for the last 25 years.
So what really drives us at WITS is that we want diversity at the decision table here. And women absolutely need to be there.
To me, a healthy data science community is one that embraces diversity.
We started WiDS with a conference at Stanford University in 2015 with three main goals that haven't really changed. First, to inspire women to join or stay in the field of data science. Second, to educate everyone by highlighting fantastic women and their technical work. And third, to support women around the world.
And wow, did we hit a nerve. We didn't even know it existed.
Fast forward to 2022,
and we have 200 regional events worldwide in more than 60 countries.
And it just keeps growing
year after year.
Last year, we were with all of you virtually. We had a 24-hour around the world event, which is very exciting. So despite the pandemic, we got together and we created this global community. We had speakers from over 25 different countries, and it was wonderful.
And one silver lining
in an otherwise tough year in 2021
is that attendees
to WiDS regional events
could
be from anywhere in the world.
We also saw
really interesting collaborations, WiDS ambassadors coming together
to host
events in Africa,
Saudi
Arabia,
Colombia, and Central and Eastern Europe.
One of the things I really love about WiDS is hosting the WiDS podcast. We now have listeners from over 160 countries, which is just incredible. And many different
And I'm also really
excited to announce that we'll soon have a co-host of the WiDS podcast, Cindy Orozco.
We also had amazing participation in the WiDS Datathon this year. Over 4,000 registrants in the Datathon from over 90 countries participating in a challenge related to climate change. And a big shout out to all the WiDS ambassadors who held workshops. We had over 40 workshops across the world.
I hope we also lift our heads above the horizon and think more than just about this moment in time, and think about the goals that we have for our young women and our young girls who'll be leading the next generation.
With the WiDS Education Outreach Program, which is focused on secondary schools, we've delivered materials to collaborators in over 50 countries around the world. We've had a great year despite all the challenges in the schools with COVID. We've had pilots everywhere from Covada, India, to New Haven, Connecticut, to a refugee camp in Jordan and beyond.
New last year were the WiDS workshops, where instructors provided dozens of workshops that were attended by thousands of attendees worldwide, online.
These WiDS initiatives would not be possible without the generous support from our sponsors. The global visionaries, innovation leaders, and everyone at Stanford.
One thing we've been very excited about this last year is working on what we call the WiDS Academy. We got interested in understanding better what the barriers were for young women and for minorities to enter this exciting field, and how we could possibly remove those barriers. What sort of programs could we put in place with partners all over the world to help?
Our ultimate aim with WiDS is to increase the percentage of women in data science, to achieve at least 30% women across all domains and at all levels, from students to senior leaders by the year 2030. And we call this 30 by 30. We believe 30% is a tipping point. That's when women truly believe that they are part of a group and they can contribute and have great impact. And we hope that you join us all in reaching this big goal.
For now, though, whether you're at Stanford or one of the regional events worldwide or just in your living room, you are a part of the WiDS worldwide movement.
Welcome to WiDS!
So that was a quick intro on what all WIDS is. And this chapter for Mumbai and Kerala started in 2018. And we've been trying to emulate the same energy and create a platform for women working in data science, women working in the field of data analytics. And every company is a data company now. So I think there are so many women who are working in different places, and we are honored to have today with us Richa Tripathi, who is one such amazing woman. And I'm very honored to share how she has taken out the time and decided to tell us about her work and a wonderful topic. Richa is a manager at Google, and she is leading a global team of analysts who leverage data analysis, machine learning to keep products at Google safe. So she has more than 12 years of experience in setting up and growing analytics teams, in creating data-backed solutions for various business problems, which range all the way from ads, loss forecasting to detecting fraud. Richa is also a big believer in the use of technology and particularly machine learning to innovate problem solving. Thank you, Richa, for joining us. It is amazing to have you on a Saturday. All yours. I think you're on mute.
Yeah. Thank you so much, Julian. This is such an amazing opportunity that you've provided me, and an honor to speak to this community of women data scientists and other people who participate in data. Because when I was starting out my career, it wasn't a well-known, it wasn't a well-known path or an area where people went to work. But I think data science is especially blessed, because from the very beginning I've seen a lot of women participating in this field, and that is extremely critical. And I really resonate with the mission of WITS, because as we build more and more of our solutions for solving global issues, we need that diverse perspective. And having more women, having more other communities that are not well represented in the mainstream in data science is an extremely crucial step towards that end. So I'm incredibly honored to be speaking today. I wanted to share some of my experience in the use of data and machine learning in solving one of the biggest challenges that we see in online products, which is of fake reviews. Julian, if you can present the deck right now, yeah, we can walk through it. Right. So today, that's what I'm going to be focusing on. That how do we detect fake reviews using data and ML? But before I come to the problem, I'll build up a little bit on what are some of the machine learning techniques that we use, some core concepts of machine learning, why machine learning, and all the other things. Can we go to the next slide, please? Or I can navigate, right? Yeah. Okay. Thank you. So first of all, let me begin by talking about what is machine learning, because data science is a space where there is a lot of chatter about machine learning. Everybody is building machine learning solutions. Everything that you hear is about machine learning. So I wanted to kind of spend some time there decoding some of these commonly used terms and understanding what they really mean. Now, you must have heard interchangeably some of these three terms like artificial intelligence, machine learning, deep learning, but there are some slight differences between these three. So let me begin by classifying them, and then we'll go on deeper into each. What is artificial intelligence? So artificial intelligence is anything like that makes a program or a computer look to be taking intelligent decisions, right? It is the science of making things seem smart, and this is done essentially through defining step-by-step algorithm. So you tell a computer, okay, take a right, take a left, go straight. That kind of it seems like the computer is acting intelligently, but there is behind it like a very complex set of instructions. So that is artificial intelligence. Now, what's machine learning? So, machine learning is the next level or the more advanced step of artificial intelligence, where you get computers to solve problems, but you don't give them any rules or step by step instructions. You help them learn. So, similar to like, how we learn a concept, computers will learn a concept and then they try and apply that concept to different solutions. So, that is more machine learning, which is more generalized, which is not a step by step instruction, but more a set of heuristics, a set of concepts that the computers apply. An even more advanced level of this is deep learning, where you're not even giving like these basic concepts or like the basic set of instructions. Instead, the computer is emulating scenario like a brain, where there are neural networks, there are many interconnected pathways, and it's working from a deep logical structure. So in such cases, it's able to solve even like very complex problems without much data available. However, like deep learning is the next frontier of machine intelligence, and that's not we are going to be spending our time today on. But I wanted to clarify these differences because these terms are often used interchangeably. Our focus of the session today will be on machine learning, which is the science of getting computers to solve problems without giving them specific set of instructions. Now, when you hear about machine learning, there are some key concepts that come into play. You'll hear about model, hear about data, training data, you'll hear about tests, you'll hear about predictions. So I just wanted to touch upon some of these key concepts. So machine learning is a process that, using data, trains a piece of software that's called a model to make predictions when we give it a certain input. So if we want to compare it to a real world example, think about how we learn a language. When we start learning a new language, we gather some basic words and understand their meanings, probably their etymology. Then we try and understand the grammar and the syntax of that language. So if you're learning Spanish, you'll learn some basic Spanish words of he, him, she, her, the, a, etc. And then you learn like how these sentences are pieced together, so that the rules of the grammar, and then you learn the syntax, what comes before what, and so on. By using, and then you'll get some examples. So your language teacher may teach you, a sentence. This is an apple. This is a boy. He is a boy. She is a girl, etc. And so you will get some of these examples, which is sort of the labeled data. Learning from these examples, you develop in your, you learn from it and you develop some combinations. Then when you are encountered with a new object, you try and create a new sentence. And your teacher may tell you, okay, this is a correct formation, this is not a correct formation, and that is the training that you are getting, that this works, this doesn't work, and that again, like in turn, builds internally a deeper understanding and a concept. So after doing this a few times, then you start to predict meaning of new combination of words and sentences, and then essentially you are able to learn a language. So building a machine learning model is very similar in that sense, that you have some examples, you feed these examples, the model tries and learn patterns from these examples through various techniques. And then in the end, whenever a new input comes in, it tries and makes a prediction based on that input. So if you see to the right, that's kind of how the model training works. There is training data, and there is a prediction that comes out of the model. You test that prediction against some existing data to take the feedback that whether it is correct or not correct, and then that goes in the loop. So I spoke about training a model, like how do you train a model? There are multiple ways to train it. And so it can basically be divided in these four key actually three key areas. One is a mix of the other two, but there are four key ways to train any machine learning model. The first is called supervised learning. Now, what does supervised learning do? As the name suggests, supervised learning is like, for example, the teacher example, right? There is a teacher who is teaching you stuff. He's giving you, labels on data that whether what you're doing is correct or not correct, correct or not correct. And based on that, you form a design in your mind, or you learn a pattern to say that, okay, this is the correct thing, this is not a correct. If the output is this, then right. If the output is this, then wrong. So this is kind of the supervised learning, where you have known outcomes and you have inputs and you know the connection between the two. So given an input, you know what the outcome is going to be. So this sort of supervised learning is used to train models like text classifiers. So saying that whether something is a bad sentence or not, whether, like, say, a tweet is a positive or a negative sentiment, because you have seen a lot of let's say text earlier, where if a particular word or a string of word comes, you can say that, okay, this is positive, otherwise this is negative, and so on. And based on that relation between the known outcome as well as the input that you are giving, you are able to build a classification system where if a new sentence comes in, you are able to say that, yeah, it is a positive or a negative thing. Next, we come to unsupervised learning. Again, as is very obvious from the name, in unsupervised learning, there is no supervision. So you don't have the relation between your inputs and the output. So you don't know in many cases like what the outcome is going to be if this is the input. In that case, the what the model tries to do, or what the patterns that we try to build, are the internal similarities between the given inputs. So maybe it could be like, in a bunch of people who are shopping together, how do you cluster them to, how do you separate them to? So some people might be buying a lot of books, some people might be buying a lot of makeup. And so the algorithm will kind of build these two classification systems and say that this group is interested in books, this group is interested in and this group is interested in, let's say, beauty. And so this is the kind of classification that an unsupervised learning can bring. Now, what is the outcome of that classification? We don't know, because there are no associations of the input data with the output data. This is useful whenever we want to do clusters. So if you have a large population and you want to create customer segments, this becomes useful there. If, let's say, you want to recommend new products to a particular segment, then it is useful there, because if you know which categories people belong to, you can maybe guess some of their preferences. And so that's how it kind of plays out. The third one is a semi-supervised learning, which is a combination of both a supervised and unsupervised model. So it merges classification and then clustering as well. So things like identification of cats and dogs images. So you don't know, because there are like millions of cats and dogs images, it's not possible to have label data for each of them. So we cannot do supervised learning straight away. So we begin by doing unsupervised learning, and the algorithm tries and sees, okay, if someone has a tail like this, it's probably grouped together. And if something has whiskers like that, it's grouped together. So they roughly form a group of dogs and cat images, and then we can take samples from those groupings and label them, and then build a combination of this classification and then a supervised learning kind of algorithm. So that is a mix of both supervised and unsupervised. The last is reinforcement learning. In this, a program learns through interaction with its environment. So it creates like a simulation, and then based on how it is rewarded, like whether it gets a good outcome or a bad outcome out of it, is how the program then tries and learns the rule of the game or the patterns. So games are, yeah, like I mentioned here, there's some examples of the reinforcement learning are games like chess, like a computer learning to play chess or go, or let's say we build a robotic hand and we how do you teach like that hand to move where it's possible to move, where it's not possible to move. And so let's say if it moves in a place where where it's really an unfeasible motion, then there is either a break or something which gives the reinforcement to the hand that you don't need to go there, and so next time it will avoid. So that's the kind of more sophisticated self learning that happens in reinforcement learning. And this is kind of out of scope from our discussion today. We will be mainly focused on these top three learning methods of machine learning. Some of the techniques that are used for supervised and unsupervised learning, you can see here. Supervised learning is regression, either linear or logistic, which is like kind of fitting a line or a log curve. And then decision trees or random forests are some good examples of supervised learning where there is data that outcomes are labeled and the inputs are attached to the outcome. So we know that if you do this, if you do A, you will get an answer of Z and so on. And based on that, there is a curve fitting that happens, or a decision tree logic that happens. In unsupervised learning, because it is mostly used for clustering and clustering, etc., we use like density-based clustering or principal component analysis and k-means clustering techniques. Like I mentioned, semi-supervised will be a mix of the two above. In reinforcement learning, there is a very wide use of deep neural networks or artificial neural networks and so on. Now, as we talk about models, a model is at the end of the day a tool to solve a real world problem. And while we can, talk a lot about the techniques and how to build a model, what is the data to be used, what is the outcome, etc. At the end of the day, your model is only as good as the solution that it offers to that real world problem. And so how do you measure that whether a model that you build is good to use or not? Like how trustworthy are the predictions that that model is making? Because the purpose of that model is that in the end you don't need to actually look at everything, and you're assuming that that model is making decisions that are true to the real life decisions that any human being would take. So it's important to ensure that you are comfortable with the performance of your model. When I say performance, how do we actually measure the performance of any machine learning model? So I want to spend a little bit of time, because whenever you build any kind of automated solution, it is important to know what the outcome they are going to give, and then what is the margin of error in that outcome, so that that can play a big role in your real life decision making. For machine learning models, there are these three key metrics: accuracy, precision, and recall. Now, if you look at the box here, you'll see that there are some actual values. So, actual values of positive or negative. Now, positive or negative is basically the prediction about a patient having tumor, and we did this for, let's say, 100 samples, 100 patients, and predicted that whether a patient will have a tumor or not. So positive means yes, they have a tumor, and the negative is that they don't have a tumor. So this is the actual values, and then there are some predicted values of, again, a patient having a tumor or not. When the actual and the predicted values meet, and they are both positive, let's say the actual result of that patient is also that they have a tumor, it's positive, and the predicted result is also that they have a tumor is positive, that's called a true positive, where the prediction and the actual result both are the same. When it is negative in both cases, it's called a true negative, because the predicted and the actual value are both same. But when there is actually a tumor, but the model is predicting that there isn't, that's called a false negative, because the model says that there is no tumor, however, there is one. And similarly, like when the model says that there is a tumor but there isn't, that's called a false positive. So these are like very central concepts to machine learning model outcomes: the true positive, false positive, true negative, and false negatives. Because the false negatives and false positives are where your tolerance of the decisions that the model is making will, fluctuate. So for example, in this case, when the prediction says that, you don't have a tumor, but you actually have a tumor, that can be extremely costly to the patient. And so when we build like such a prediction model, we want to make sure that we minimize the false negatives. Now, in some cases, the false positive might actually be very sensitive. So if I take the example of the reviews itself, like someone is, say, let's say, a very dedicated consumer of products, and they really want to share their opinion of a good product. And they say, this is a great product that I bought. I'm really very happy with it, and I would like people to experience it more. But our models actually, flag it as a fake review and take it down. So that becomes a false positive because it was a genuine review, but somehow, because of some reasons, the model said no, it's not, and it was taken down. That can actually hurt the customer experience. Now, it's not very like as severe in this case as the false negative in the cancer case, but there can be real world scenarios where false positive tolerance is very low. And so when we build a model, we have to kind of optimize for the tolerance that we have, either for false negatives or for false positives. So now let's talk about these three key model metrics. What is accuracy? So accuracy is defined as the value which comes that out of all predictions, how many correct predictions you have made. That is the accuracy of the model. So in this case, the true negatives and the true positives are the actually correct predictions that the model has made. So as you can see, the formula is true positive plus true negative divided by all outcomes. What is the precision? Precision is that out of all the positive predictions, what is the percent or truly positive? Like, this true positive out of all that could have been positive, so true positive plus false positives, that is your precision. And the recall is that out of all positive predictions, what is the percentage of correct positive predictions? So this is, your recall. So if we just calculate it, you'll see the accuracy of the model is 70%, which is not a very high accuracy. I mean, I think sometimes it may be tolerable, but usually these models operate at a very high level of precision for any good outcome, and especially in scenarios that are sensitive. So 70% is, kind of average accuracy. But if you look at the precision, that's extremely poor. It's just 30%. So like out of all 30% positive values, it's out of all positive values, only 30% it's predicting correctly, which is uh, only 30% are truly positive. So this is not a good precision number. Recall is 50%, which is like neither here nor there. But this is one way to understand how well your model is predicting against the real world situation. So this is one performance criteria. By the way, I just wanted to say that, if you have any questions, please feel free to put it in the chat box, or we can take later as well. So now, as we have understood a few things about machine learning models. What are machine learning models? What are the different kind of machine learning models, or the techniques to train a machine learning model? And then how do you measure the performance of your model once you built a model? These concepts being taken care of, I want to now move on to how do you plan a machine learning project. Now, it starts with, first of all, framing the problem, right? What is it that you want out of that ML model? What is it that you are looking to solve? Sometimes, actually, building a machine learning model may not be the most ideal solution for a real world problem, and there can be simpler methods to do it. It can be like a sheet in your Excel that can take that do that job much more efficiently and with much lower cost. Because machine learning models can be expensive to train, they can be expensive to maintain, they need they need regular training, they need labeled data, which means there is going to be some investment in operators for labeling the data, etc. So first step is to kind of question that whether your problem really needs a machine learning solution. In cases where the data is huge, where the need to label stuff, like you need to label a lot of stuff, or where you need to predict predict very complicated situations, machine learning is definitely a plus there, and it is worth all the investment. But for a smaller amount, for a smaller volume, or places where you need to be like very clear about what has happened, like where you can see the path of how that prediction has been made, it may not be the best solution. So thinking hard about the need of an ML solution for a problem is extremely important. Now, once you've made the decision that yes, you want to build a machine learning model, and that's going to be a good solution for your real world problem, you move on to the preparation of building such a model. And for that, the first step is data collection, data labeling, and setting up an engineering process. Now, you know, data is the foundation on which any of the machine learning models are built. And your model will only be as good as the quality of data that you feed into it, the quality of data that you use to train your model. So this step is extremely crucial. I cannot overstate its importance. Sometimes people build, models that are trained on whatever data they have at hand, and that might work well for one of your test cases, but it will break pretty quickly. So making sure that when you are collecting data, when you're labeling data, when you are cleaning your data, you're taking into account a lot of these factors of what your future use cases are going to be like. For example, you have to ensure that your data is not biased. So let's say if you are measuring the average height of people in US, you're not only looking at a sample of data that has only men's height, that you're also considering the height of women, that you're also considering the height of all minority groups, etc. So making sure that your data is not biased in any way for the purpose that you are going to use it. Then you have to make sure that you're not over indexing on any particular PII information, like where a person lives, or what is the race or gender or ethnicity of a person. So like these are some of the considerations that you have to be very aware of when you are sampling this data, because the data that you feed is what the model will learn, and that's based on that it will make predictions. So that becomes a vicious loop if we are not careful in the very beginning. Yeah. So when going to data collection and labeling, some of the primary considerations are that what is it that you want to label? Now, in case of fake reviews, for example, what I want to label is whether a review is fake or not. So that's the kind of label I want to collect. I want to collect information about the reviews, and I want to collect the labels that those reviews were given. So this is what is the time frame. Sometimes you may want to collect data for only the past month, sometime for the whole year, for sometimes for going back to 20 years. It depends again on what you want, how fresh of a data you want. Sometimes stale data may bias your results in a different kind of way, and so you don't need a very long historic data, but sometimes you may need to capture that trend, and so you need a very long time frame. For example, in loss forecasting, because there are economic cycles, and to take that into account you need a longer time frame of data. Then how would you collect this data? So let's say I want labels on whether review is fake or not. How do I do that? Do I use operators, human operators, who will sit down and label these stuff? Do I use some sort of other heuristics to label stuff? Do I use crowdsourcing, like asking, creating a game out of it and collecting? How do you want to collect this data? Where will you get it? And then labeling is called ground truth. Ground truth is, right, what actually happened and what is the real outcome of that. So these are all the things that you have to keep in mind when you collect your data. When you have it, you move on to the next step. And the next step is about model training and debugging. Now, this is probably the most iterative process of all. You have done your preparation. You have made a business problem into an ML problem. You have understood what data needs to be used, and now you come to actually training the model. Now, this can be a very, very iterative process. For that first thing that you need to do is feature engineering to kind of understand what are some of the key features that your model will have. What is like the concept or the key concepts that your model will learn, as our previous example of the language learning. So this feature engineering, it can be done either manually or automatically, and analysis of data plays a very key role here. You want to look and feel and understand your data. You want to slice it, dice it, dress it in different colors, and see what it yields, to understand like what your underlying data is saying, and based on that create some key features. So that's what the feature engineering is. And then another thing to keep in mind is that the labels that you're going to predict are balanced. So sometimes, negative labels can outweigh positive labels, which means the data is not providing enough for the model to learn about positive labels. So it may make then random predictions which will not be close to the ground truth. So in case of spam itself, right, you let's say get 100 reviews in a day. Out of that, probably 5 are bad and 95 are good reviews. That means they are not fake, and the only fake reviews are 5. So if you feed this data as it is, the model will not have enough examples of fake reviews to learn to form a pattern. So here there are multiple techniques to sample, like you down sample the negative labels and up sample the positive ones, or you upweight them, and so on. Sometimes the labels can be wrong actually. People can mark a good review as fake or not mark a fake review as fake, and so you have to also account for those errors. So this is some sort of this requires a little bit of statistical thinking, and also a lot of iteration, because every model that you build, from that you will learn what's working, what's not working, what more you can improve on. And so this takes a lot of time in iterating. Some may be easy to build, sometimes it can take a lot of time. So in terms of time planning, I would say this is the step where you should have a flexible planning, because this can be quite an iterative process. After going through this, you have a model. Now, what do you do with it? You actually want to use it, right? So, but are you ready to use it as soon as you have a model in hand? No. We have one last step before we do that: testing. All right. Uh, Testing the model with real world data, that is extremely important. So earlier I had shown you a slide where there was a split of the data into 3 parts, and those 3 parts are like, one is for training, the other is for testing, and the third is for validation. So this testing data is extremely important. It is completely independent for the data that you trained your model on. Now your model has learned a structure, a pattern, a concept, and it wants to make predictions. So you feed it the inputs of the testing data, and it throws some output, makes predictions. Then you compare those predictions against the outcomes that are already given in the testing data, and see how far it is from the actual side. So in that case, you look at the number of your, true positives, false positives, you calculate your model precision recall, etc. And that's what tells you whether your model is good to use or not. If you're not happy with that performance, you go back again to training and debugging and, iterate that. But if you're happy with it, then your model is probably ready to be used in the real world. And I think a good rule of thumb is to always start with running the model in a shadow mode where it's not actually making decisions, but simulating those decisions so that you have some monitoring on it, so that you can monitor those responses for a while. Be satisfied that yes, the predictions are tolerable, are good, they are robust, they are tackling all different kind of cases, they are not showing any bias, and then once you are satisfied with that monitoring outcome, you are good to deploy the model. So that's kind of the whole life cycle of implementing a ML project. But I have some tough news for you. Once you have deployed an ML model in the wild, that's not where your job ends. After the model is deployed, you have to continuously monitor it to see that whether the predictions that it's making are actually, are good, are accurate enough, are precise enough. And if they are, yes, we continue. But sometimes there are newer patterns that come in the input, and your model may not be, familiar with those patterns, so it's not able to detect correct outcomes for those. In those cases, you will need to retrain your model again. So that feedback loop is continuous until the time maybe you come up with a newer technique, a newer variety of model, and so on. This is what the 4 key steps of a ML project are. Now, coming on to our problem of detecting fake reviews. So I will follow these 4 steps of problem framing, planning and setup, and then data collection, the model training, and then testing and deployment. And how I used a couple of, all of these steps to build a model that will detect fake reviews on a platform. Now, why solve the problem of fake reviews, first of all? I don't know if you've ever, went online shopping, but if you've done, you see that, reviews play a huge role in guiding your decision. Almost always, so to be statistically accurate, in 95% of the cases, people use reviews as a guiding post that if the similar product has a better rating, you will prefer it over the product that has a lower rating. So people use ratings or reviews as a huge guiding post, and for any platform to make sure that they are providing this information credibly to the consumer, it is important to remove fake reviews. However, because reviews or ratings are so crucial to a customer's decision making, the merchants or the product sellers have an incentive to put fake reviews. They could do this either through, paying someone to write a good review, or writing it themselves through different accounts, through by different names, etc. So it's like a push and pull. As a platform, you may want to remove fake reviews to ensure your integrity of the data, but as a product seller, you want to have more and more, artificial fake reviews, because that will increase the rating and the perception of the quality of your product. So my business problem, speaking from a perspective of the platform, my business problem is to detect and remove fake reviews to ensure right representation of the product for customers. How does this become an ML problem? Like if I were to frame it in ML terms, what I want to do, I want to basically create a machine learning model that can label a review as fake or not fake. And if it is fake, take it down. If it's not fake, let it live. So my first step, as I mentioned earlier, was to plan the project and set up. So the question I ask is building a machine learning model the solution here, or can I do it in some other way? So I evaluated 3 ways. Yes. One way would be to, deploy all, human operators who look at the reviews that are coming and make a judgment on whether it's a fake review or not. Which is, good if, let's say, there are 100 reviews coming in a day. But if there are a million reviews coming in a day, it's going to cost a lot to employ these human operators. So it's a very, very expensive solution for me. Not completely infeasible, but extremely expensive. The second is I can write, some basic rules, and I don't need a model. I'll just write these step-by-step rules and let it work. It works fine for a given time until until the person learns that, okay, this is what is happening, so let me change my tactic a little bit, and then your rules won't be able to identify that, and the fake reviews will start slipping in again. So this works for a very short term, only till the time the market does not learn about your protection system. Which is why then I'm left with only the third option, which is to train an ML model for labeling of fake reviews. Because in this way, I don't need to use a ton of operators for labeling. I can save some cost there, and also I can do it scalably very quickly, because human labeling will also take some time. But with a machine learning model, I mean, I almost eliminate the latency. So this can be done very quickly at a very large scale, and it is a little bit adaptive because there are no fixed rules. There are probabilistic decisions that are happening. Even if the tactic changes a little bit, my model will be able to accurately label it. So I concur that yes, for my use case, which is to label a review as fake or not, and in a very high volume, yes, building a machine learning model is the right solution. So then what do I do now? I do the data collection, pre-processing of data, and then data labeling. Um, Again, like when I'm doing this collection, I want to ensure that I'm taking reviews like from all geographies, from all sorts of populations, from all sorts of products, etc., to make sure that there is a good representation in my sample. I want to take a lot of descriptive factors like text of the review, the date on which it was posted, the age of the account, the number of other reviews that the user has made, and so on. And then, I want to label some of this data. So in my case, I have, chosen to use the supervised learning technique, which means I want to label my data. But we could also do this through a mix of supervised and unsupervised labeling, because at the end, we want a spam or not spam label or a fake or not fake label for a review. And that means we need to provide some correlation between the input and output. So a supervised or a semi-supervised learning method works well here. That's the choice that I am making, and you can make a different choice for your use case. So that's why I label all my data as fake or not fake. So this is how your data table might look like. There are these columns, these features, and then in the end there is a label that is annotated by humans, and it's called like the ground truth data. So this is what is the actual verdict about that review. Right? So once I've done all of this, I go to feature extraction. So as I mentioned earlier, in feature extraction, I'll basically, conduct some statistical analysis, exploratory analysis to understand what the data is like, what's its distribution, what are some of the prominent variables. Uh, is it skewed to one end? Is it representative of the sample that I'm looking at, and so on? So I do this kind of exploratory data analysis, and then I select features for the model training, which could be automatic or it could be manual. So sometimes the model may be able to learn patterns that we wanted to learn. Sometimes the labeled data may not be enough, in which case we may have to artificially create some features, or some features that we think are important but the model is not learning. We create those manually. So it can be a mix of automatic and manual feature creation. Once that is done, we feed the label data, and we get a trained model out of it. So like I mentioned, I'm using a supervised model here. It could be semi-supervised or unsupervised, etc. And the model comes out. So we get one version of the model. When we get a version of the model, we use it on testing data to see how its predictions is and calculate the model metrics like precision, recall, and accuracy. We see that whether these metrics make sense for us, whether the tolerance is within our limits, are we happy with the precision, with that recall, with that accuracy. If not, we go back again, do some feature engineering, or maybe add some more label data or change the label data, whatever it is, to kind of iterate on this step and then come up again with a trained model. Once the model is trained, we now use it to make predictions. There's a lot of inflow that is happening. The model is making predictions, and these predictions are going out in the real world, and then you kind of keep monitoring that. So you monitor it. So in this particular case, what is happening is that reviews are coming in, hundreds and thousands of reviews are coming in every day. My model has probably learned that account age and date and the number of other reviews are a crucial factor in deciding that whether a review is fake or not. So from this example here, it seems like if your age is less, and let's go to the label data and look at this. So it seems like if the age is less and the number of other reviews that you've made is less, then the review text is kind of positive, then yeah, it looks like a fake review because someone is trying to misrepresent the quality of their product. And if your account age has been long, and you have made a lot of other reviews, you're probably a genuine user, and your whatever your review seems is not fake. So looking at this pattern, the model makes some predictions in this case. So here, hundreds and thousands of reviews come in. For each review, the model will look at these parameters, come up with a score, and then make a prediction of whether the review is fake or not. We take a sample of these decisions that the model has made, the predictions, and then we look at it to validate it. And we probably do it using human operators, where they will make their judgment on what the model has labeled is correct or not correct, correct or not correct. In some cases, there might be a lot of divergence between the human operator labels and the model labels. And in that case, you have to go back and check where your model is not working. Maybe there is a new pattern which it is not catching. Maybe the label data that you use is not sufficient, and so on. So, or some of the features that you're using is not working well for you. So in that case, you have to go back, look at your model, retrain it again with new data, or build another model altogether. So that's kind of the role of monitoring. And that's how we use a machine learning model to make predictions. So that brings me to the end of my presentation, and I'll pause here for any questions, comments.
Awesome. Thank you so much, Arusha. One quick question. When you said that you've been working on building these models within Google, is it like like you did mention that it has to be a shadow mode first, and then you decide to further make sure that there is a less or no bias almost. Like, could you explain what happens if you find out that there is bias? Like, what happens in that shadow mode? Do you change it, or like what is the process in that? I think there are a lot of companies that end up having to rework on a lot of things. I'm talking of small startups, which sometimes don't have the leeway or the number of data scientists to actually work on a different model altogether on the side. What are the best practices in that case? Like, I remember you talking about this, so I just want to understand how do you do it at work?
Yeah, absolutely. And that's a very good question, Julian, and a very pertinent one, because that's what happens. Building a model is not difficult, but making sure that the outcomes that it is giving is relevant and it's actually good is the most complex part of it. So there are two things that we do. One, yes, being in Google, we have good resources, so that's always a plus, but we never have enough resources. So even we don't have all the data scientists that we would ideally want. But before, that's probably the last step. So the first step is very, very crucial. When you are collecting your data, when you are generating labeled data, it's at that point itself, it is very important to do a lot of this exploratory data analysis and understand the population that you are using. Because if, let's say, you are trying to predict the rate of success or something, and you're looking, or the pay levels, let's say, for example, and you're looking at data that has 90% of white men only, you will get a number which is not representative of your entire real world. So these are things that you have to find out in your population in the very beginning itself, and that is why spending a lot of time on processing data, cleaning it up, making sure that you've looked at every column that you are actually including in it, how that distribution looks like, is it free of bias or not, extremely, extremely important. But let's say you have done that due diligence, but even then somehow you end up with a model which is creating biases. There are two ways to go about it. Number one, like, I think urgency plays a role. Let's say there is some urgency, you want to take these decisions right away, and you cannot spend that months of efforts again rebuilding a new model. So you correct it by artificially enhancing things on top of it. So you will either create a condition called, okay, the model, if this is like the population and this is the model's prediction, even then, like, consider it. So let's talk about the pay scale examples again. So let's say the model is predicting that for women the pay scale is pay is lower, and hence it's excluded from a success definition, so not successful, sort of. We can put like an additional condition on top of our system to say that if the population is women, the gradation will be different. Like, the model thresholds will be different for this set of population. And so even if that pay scale is like 60% of it, it is successful, because like that's what the real world is about. So you can make those enhancements on top of your model predictions. You can augment it, you can tone it down, like you can make those levers on top of it. But then at the end of the day, you also need to go back and rebuild and make considerations about the training data.
Got it. Got it. I really like the additional thresholds that you mentioned.
Yeah,
There's another question from Shyama KS. I will just read it out verbatim. Excellent
sure.
session. I am a research scholar in the domain. I would like to know what Google does right now regarding fake review detection, such as the current model or the metrics that you consider.
Yeah. Thank you, Shama, for your question. Good question. We do a lot of stuff. I'm not at liberty to say, like, obviously, talk about in detail about all of them. But yeah, we leverage machine learning in a very big way. Because, like I mentioned, the scale at which the reviews come in our platforms is extremely huge. It's not possible for us, for humans, to label everything. So we use a mix of machine learning and then human judgment together. And then we have in the middle, like, a lot of analysis that I spoke about. So whenever, we have a continuous pipeline that monitors the prediction of these models. When they say a review is fake, there is a person looking at it, at a sample of it, and actually deciding whether these are fake or not. If they are not, we send that feedback back to the model, to the modeling teams, and they kind of continuously iterate on it and improve. There are newer versions of model launched every few months, every 2 months or so. So there is this continuous iteration and improvement. The metrics that we consider to judge such a model is the three metrics that I mentioned: accuracy, false positives, true positives, so precision and recall, etc. But that's only the statistics part of it. We also also take into account a lot of subjective feedback. So we talk to users, we have user research teams that will understand how our users are seeing their good reviews either being taken down, or as a business they are seeing like a lot of fake reviews on their platform. So we take those feedbacks also in addition to the model metrics. But yeah, the metrics used are precision and recall and accuracy.
Thank you. There's another question by Ganesh. How do e-commerce websites handle fake reviews, as a recent report shows that of the identified fake reviews on Amazon, more than 99% of them are five-star reviews. I think there's
Yeah,
a
thanks. Yeah.
follow-up as well. I'll just read that as well. People are being hired by sellers to post fake reviews. Ethics problem. Are there bots being used to counter fake reviews? Yeah.
Thanks, Ganesh. And I think your assessment of the problem is spot on. Yes, 5-star fake reviews are a huge problem because of the reason I explained earlier. Like, merchants have an incentive to do that, because if they inflate their ratings, people are more likely to buy their product. And so they do that. And they buy fake reviews through these sellers. That's a real world problem that we face. And it's extremely hard because fake reviews look like, on the face of it, they look like very genuine reviews. Yeah, I used the product, it was very nice. But that's where your data analysis, or that's where the sophisticated kind of looking deep into the data yields results. Because when you go and look at the activity of probably these users, things that I mentioned, like what are different products that they have posted on, have they made this only one 5-star review, or are they actually doing genuine engagement? um, or like in general, like what is the trust of a score of like trust of the user that is posting that review based on their past behavior, etc. So these are the considerations that come up. We don't have bots to counter fake reviews. Our models are basically the bots. Like, the models are the software that counter these fake reviews. Our machine learning models identify this. In addition to that, we have flagging system, like users like yourself, if you think that there is a review that is fake, you can flag it. And we have manual operator queues that will help evaluate that and take it down. And then we use that data again to feed into our models. So we take like an ML first approach. So there is a machine learning model sitting in the front that will take this down, and then followed by human operators and analysts who are looking to uncover these new patterns of fake reviews, and then feed that as labels into the data. So that's kind of a two-tiered approach led by ML, but also backed by human operators. In fact, if you're interested in fake reviews, Google recently published a blog that shows how we counter these fake reviews on our platform. So you can read it on the keyword blog of Google. And maybe I can share the link later on with Julian, and you can share it with people.
Absolutely. Thank you. Thank you so much for the session. It was very detailed and informative. Thank you for your time. No more questions, but if anybody else reaches out, I'll definitely pass it on to you. Thank you.
Thank you. It was pleasure. Thank you. Bye.
And everybody else, please do join us next Saturday as well. We have our final session for 2022. So we'll be sharing the details in our community chats. Thank you. Bye, Risha.
Bye.